So today is kind of our last day before our quiz or our test tomorrow. So today is all about reviewing what you know. And the two main things we learned about in this module so far were line plots and how to add, subtract, and multiply fractions. Really, it's not adding and subtracting. That's from module 3, right? But basically, we learned how to use add-on to what we know about fractions to multiply fractions with whole numbers. Yes? Very good. Let's take a look at our problem of the day. It says, in an auditorium, 1/6 of the students are 5th graders, 1/3 are 4th graders, and 1/4 of the remaining students are 2nd graders. Be careful. These words right here are so important. Of the remaining. Because is it 1/4 of all the students? It's only 1/4 of the remaining students are 2nd graders. The question's asking if there are 96 students in the auditorium, we want to find out how many 2nd graders there are. Okay, the important information is we need to know altogether there's 96 students. 1/6 of the students are 5th graders. 1/3 are 4th graders. And 1/4 of the remaining are 2nd graders. Does that mean there are 1/6 5th graders there?
No.
It means there's 1/6 of how many?
96.
So how could I find out how many 5th graders there are? I would have to do 1/6 of all the students, which is?
96.
So that's the same thing as 1/6 times 96. Do you agree? How would I do that? It'd be 1 times 96 all over 6, which is the same thing as 96 over 6. How many times is 9, which is the same thing as in standard algorithm, 96 divided by 6? How many 10s do I have?
1.
How many times does that go into 6?
1.
Okay, if I subtract that, I get 3. How many 6, and then if I bring down, I get 36. I know you can't see it, but you could write it. How many times does 36 go into 6?
6.
So how many 5th graders are there?
16.
Okay, so we should write at the bottom here, 16 5th graders. Is that the answer?
No.
Okay. That's just some information we're going to need. Okay. What about 4th graders? Is there 1/3 4th graders? Is there a third of a 4th grader in the auditorium?
No.
Then why does it say 1/3? It's 1/3 of,
96.
thank you, of 96, which as we know is 1/3 times 96, which would be 1 times 96 over 3, or 96 over 3. How many times does 90 go into 3?
30.
30 times. How many times does 6 go into 3?
2.
So how many 4th graders are there?
32.
Okay, so we know that there's 32 fourths, or 32 4th graders. Okay. Now that we know that there's 16 5th graders and 32 4th graders, do we do 1/4 of 96 to find how many 2nd graders there are?
No.
Why not? How come we can't? Because over here we did 1/6 of 96 and 1/3 of 96. It says 1/4. So how come to find the 2nd graders, I can't find 1/4 of 96? Stella?
Because it's 1/4 of the remaining.
Oh, so I have to figure out how many kids are remaining. So how many kids are there all together?
96.
96. Okay, it's tape diagram time. Go ahead and draw a tape diagram. That represents all of the kids in the auditorium. How many kids is that? 96 students. Very good. How many of them are 5th graders?
16.
Okay, so these ones are the 5th graders, and there's 16 of them. How many of them are 4th graders?
32.
So these are the 4ths. And there's 32 of them. Everyone else is something of the remaining, right? Would you agree? That this part right here is what's left over, or this is what's remaining. How can I find out how many students are remaining? I can take 96 and take away 16 and take away 32. What's 96 minus 16?
80.
Okay. And then what's 80 minus 32?
48.
So how many students are remaining?
48.
48. Now what fraction? Now let's just zoom in on that remaining part. Okay? So it's like I'm going to take this remaining part and just zoom in. Does that make sense? This became this. Okay? Very good. So now this entire piece of tape is how many kids? 48 kids. Yeah, because that's what's remaining. And what fraction of that remaining is 2nd graders? 1/4. So only this part right here, not all of the remaining, only 1/4 of it are 2nd graders. So in order to find how many are 2nd graders, I have to find 1/4 of what number? Very good. So do you see how reading the problem carefully is very important? Okay. 1/4 of 48 is the same as what multiplication sentence, everyone?
1/4
Which is the same as what fraction, everyone? Which is? 12 second graders. Okay, once again, it's just very important to read and understand the question carefully. So number 1A says 1/2 times 7. That's how many copies of 1/2? How many copies of 1/2? 7. So you could draw 7 copies, 2, 3, 4, 5, 6, and show that this is 1/2, and we're trying to find what 7 copies of it are. That's not the only tape diagram you could draw, though, because we know that the multiplication sign could mean what? Of, right? So could this also be 1/2 of 7? Could it be? So I could draw my tape diagram and show that this is equal to 7, and I'm trying to find half of it. Will those two tape diagrams have the same answer? They sure will. So do you have to draw both? No. But I want to show you that both of these examples are fine. You can think of it as 7 copies of 1/2, like this one, or you can think of that as 1/2 of 7. Okay, so pick whichever one makes the most sense to you. If we're thinking about it as 7 copies of 1/2, it would be 7 times 1/2, right? Yeah. Which would be 7 times 1 over 2, which would be 7 over 2. How many wholes do I have in 7 over 2?
3.
3. And then how many halves left over?
1/2.
So the answer would be 3.5. And again, this way, the tape diagram is showing that we're making 7 copies of the fraction 1/2. Now, what if we're solving it this way? What if we're thinking about it as 1/2 of 7? Well, we could find how many units do we have altogether?
2.
We could write that we have 2 units, and the 2 units is equal to what? 7. So then 1 unit would be equal to 7 divided by, right, or 7 over 2, which then, again, is 3.5. Okay, so do you see how both answers, both ways you think of it, you get the same answer? Question number 2 says, circle the expression or expressions that give the same product as 6 times 3/8. Explain how you know. So when you explain, you have to explain using words. I'm not going to be explaining using words, writing it down, but you need to do that at home, okay? So let's take a look one at a time and see if these expressions are the same as 6 times 3/8. Now, expression number 1, A, says 8 divided by the sum of, or the product of 3 and 6. So how would you write that as a fraction? What would be the numerator? Everyone? 8. What would be the denominator? 3 times 6. Do you guys agree that those are the same thing? Is that the same thing as 6 times 3 over 8? If I wanted to write 6 times 3 over 8 just as one fraction, what would be in the numerator? Everyone? 6 times 3 all over 8. Is that the same thing as what we see in choice A? No. So A is not equivalent, so do not circle it. What about B? How would I write B as a fraction? It would be 3 divided by 8 and then times 6. Do you guys agree? Now how do I write that as a fraction? A single fraction. It would be 3 times 6 over 8. Is that the same as what I have in red? So is it equivalent? Very good. Circle it, and then at home you can explain how you know. What about C? What would be in the numerator? 8 divided by 6, like that, and then times 3. Do you agree? What would be in the numerator if I wrote it all together? 8 times 3, all over 6. Is that the same as what I have in red? No. What about D? I have 6 times 8. What would be in the numerator? 6 times 8, all over 3. Is that the same as what I have in red? No. Is it? No. What about E? What would I have in the numerator? 3 times 6, all over 8. Is that the same as what I have in red? Very good. we just got started on the line plot. As Supan pointed out, we can't finish because we don't even have all the data in our chart yet. So tonight you're going to finish the rest of this study guide to help you prepare. Does that make sense? Very good.